Yeah, okay. Hello, all. It's a pleasure to welcome you all to SiriUs Talks, um, where we will be delving into penetration testing. And my name is Naresh Subramaniam. I'll be your moderator for today's session. Yeah, today's presentation promises to be both insightful and informative as we explore penetration testing, whether you are new to the subject or a seasoned expert. I'm confident you will gain valuable insights that you can apply to your work and your projects. Yeah, before diving into the presentation, let me provide you with a brief overview of what to expect from this session. Yeah, we will start by case study where we will explore recent cyber attacks on connected car, and next we will move on to the automotive threat landscape, pen testing process, and reporting. Finally, we will conclude with the QA. So where we'll have an opportunity for questions and discussions. So please feel free to ask questions in Q&A window. Yeah. So yeah, now without further ado, I would like to introduce today's esteemed speaker, Ishwara Prasad. Ishwara Prasad is a head of cybersecurity at Siri with expertise in cybersecurity and battery management systems and functional safety. So with the several years of experience in automotive, so Ishwara brings a wealth of knowledge and insight to our presentation today. So over to you, Ishwara.
Yeah. Thanks, Naresh. Thanks all of you for joining this series talks about automotive penetration testing and ethical hacking. So before going into the topic, very briefly, small information about our company SiriAB. So SiriAB provides software development and consulting services in the R&D of automotive, telecom, and IoT domains. We basically specialize in cybersecurity, functional safety, battery management system, infotainment, ADAS, and software-defined vehicles. So our customers are OEMs and Tier 1 suppliers. We started our operations in 2011 and have our headquarters in Gothenburg and Sweden. So our delivery centers are also located in Darmstadt in Germany and Hyderabad in India. Okay, so with that, let's start our topic today. Okay, so you know, car hack is becoming a daily news now. So last month, you may read about this news with the headline that $40,000 Tesla is hacked by $169 Flipper Zero. So what exactly happened here? It's basically a very simple cybersecurity hack that is demonstrated in this hack. So it is a simple possible phishing and social engineering attack on the Tesla car done by the white hackers. The white hacker is basically the one who do the ethical hacking. So what is done here is simple. Attacker used a Flipper Zero and a Wi-Fi development board to broadcast the fake Tesla guest Wi-Fi network. So it's a rogue network where users are prompted to get a free Wi-Fi and enter their username and password. And once they enter their username and password, the Flipper Zero can snip all those data, and the user will get a two-factor authentication code. That code also snipped by the Flipper Zero. So that means the hacker now get all the information related to the person about his login ID, password, and authentication code. So what he will do is with that, he will log into in his mobile. The hacker will use this two-factor authentication code, the login and such information on the Tesla app, the car app, and he will log in. It should be done immediately, and he will now get access to the car. That means he can start seeing the location of the car, and then by using the Bluetooth and location service on, only with his iPhone alone, he is able to control the car. Like he can switch on the lights, open the doors, etc. And then finally, even he can drive the car and go with that. So all this happened with just a small device, Flipper Zero. This can also be done by a laptop, of course, because it's a rogue Wi-Fi network. That is the starting point here. But the thing is, with such a small device, it is not easy for another person to know that hacking is happening. So this is one attempt done by white hacker, and it's not the only one. This is very recent, happened last month. But if you see the news is from old, from 2015 onwards, the hacking started. So this news is where a big recall of 1.4 million Fiat Chrysler cars happened. And what happened here is the user taken the control of complete car, that is steerings, brakes, everything is under the remote control of a hacker. So this is fortunately a white hack, but you can imagine when you are going in a high speed in an autobahn, what will happen if your brakes are not controllable or you cannot turn the steering. And it's another case where again Tesla, yes, is hacked, where using the chain of exploitations, the attacker basically able to control the car by his iPhone. So you can imagine how the continuous hacking is happening there. And this is one more event where one more issue happened with the hackering, where thieves are able to steal the car by forcing the headlamp opening and then access the canvas. So they saw that canvas is going through the vehicle headlamp, and then they are able to simulate the signal to start the vehicle. So with all these newses, you can understand the importance of performing ethical hacking or penetration testing to understand the weakness of the car before it is released on the road. Okay, so now let's see what is the automotive threat landscape. So a car has 100 million plus lines of code. So as you know, it's impossible to write a perfect code without any vulnerabilities in such a high volume of software. And it has all possible connectivity of the world, more than a laptop or a mobile. And easily 40 plus ECUs have cybersecurity properties in it, which has a software update possibility or connectivity. And there are multiple in-vehicle communications like CAN, LIN, FlexRay, MOST, Ethernet. So they are all exchanging highly critical vehicle data. So if somebody snips it and try to do the man in the middle attack, they can achieve or they can take complete control of the car. And car is getting advanced, as you know, day by day. We are going towards full autonomous driving, where software is taking control of the complete car, and there is a over-the-air update for firmware, and also there is a vehicle to different connectivity like V2X connectivity, what we say. So more than all this, car has a lot of exposed systems also, like charging port is coming now, where there is a PLC or CAN communication is happening with the external charging station. There is an OBD port where tester can be connected, and there are keyless entries where simple RF communication is happening. So the threat landscape in automotive is really very, very huge. So much bigger than any device in this universe, as you can understand from this picture. But unfortunately, the focus on adding security on the car is not that great level as it is happening in banking or other domains. But definitely it is going to change in future. So, okay, so with that, let's see, learn some basics about ethical hacking or penetration testing in simple wordings. So initially, with four Ws and five Ws and one H, we will learn it. So basically, what is ethical hacking? It's simply simulating the real world cyber attacks of the automotive system using some sophisticated tools and techniques. And why it will be conducted? So basically, one is the general security of the car. It's important. And also it should be compliance to the UNEC WP29 RN 155 regulations that is going to be effective from June this year. So that means all vehicles, all road vehicles basically should undergo this certification, and they should prove that the automotive system is free from vulnerabilities or threats. And when this should be executed. So normally this will be executed after the development, but actually it can be done before also, or it can be done before and after both, which is very good because implementing security measures provides us where there are weakness, and after implementing will prove that we are sufficiently uh, had the safety measurements or security measurements in place. And where it should be executed, yeah, it should be executed initially in the test bench because we should be able to access all the ECUs and the inter-network connections, and later in the vehicle how a hacker can hack it. And who should do is definitely it should be done by an expert white hacker who has the knowledge of automotive issues and how it should be done. So that is the part of this presentation. Basically, it should have a threat modeling and vulnerability analysis followed by the exploitation tests. Okay, so let us go further about what is this process of penetration testing. So it's very important mindset that all ethical hackers should have. Pen test is an engineering process and it should be executed systematically. So it is not just a testing, it's a process and it should be executed systematically. So the picture here shows the presentation, penetration testing framework, which can be used to perform a perfect execution of it. So I will explain all these steps in further slides. Okay, the first step here is understand the system and its scope. It's not a black hat hacking, so it's important to gather all technical documents like architecture and the technical details. So we should understand the scope of test because test can be performed based on user functions, or this can be done even based on the components that is used in a vehicle, and also based on the connectivity and inter-vehicle communication. So basically, it's important to understand the scope of the testing and collect related documents. The next step is to distribute the roles. So here it's not that only the pen tester has the role, it's also the customer has the equal responsibility. So it's a distributed role and it should be executed like any other project management. And once that is done, next is the time to go deep into the technology and to understand the architecture, the components used, available connectivity, and networking of the target. So a deep study of the system will definitely give a big insight on what should be tested in further steps. Finally, all those investigations to be summarized to form a footprint of the target. So by reading this footprint, anyone can understand what all the technology used, which component, which microcontroller used in it, what technology used, etc. So the next step in the framework is threat modeling. It's basically a theoretical aspect of understanding the threats and risks of the target system. So what we do in this threat modeling is initially to create asset registers. A component or a user function has multiple assets. So identify the assets because identification is the key to identify further threats. So the next step is to decompose and to prepare the data flow diagram. So which are all the inputs, which are all the outputs, from where to where it penetrates. Such kind of a data flow diagram should be drawn. And the next step is to identify the threats to the system. So we can follow the model called STRIDE, where spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privileges, etc., can be checked to identify whether such threats are available to that particular asset and finally to a component or user function. So the next steps there is to group the threats into different risk levels because we may identify a huge number of threats and it may be not possible to fix everything because of the technological uncertainties or cost of the product. So then it's important to group the risk into different levels of risk, and you can use the technology of DREAD for that. That is the damage potentials, reproducibility, exploitability, affected users, and discoverability. So once the risks are categorized into different levels, we have to go for the security objective definition. So identify the security objective that should be tested in the penetration testing. Yeah, this process is a continuous process, so we can continuously perform it because once we identify the register, decompose it, and identify the threats and do the risk level, it's new risks might come, new incidents might be coming in the market, which is also important to understand and take proper actions for that. So once threat modeling is done, the next step in the penetration testing process or framework is to do the vulnerability analysis. So vulnerability is nothing but a weakness in the system. So it's a process of identifying and quantifying and prioritizing the weakness of the system. So basically, the risk level will be cross-checked for the impact on our target system. And vulnerabilities in the third-party tools, firmware, stacks, HSM, etc., are to be considered by referring to their database. So we have this common vulnerability scoring system and related database maintained by different suppliers. So we may be purchasing firmware from a tier one or tier two supplier, and we may be purchasing a silicon from a silicon vendor, and like this, we are taking multiple sources of software and hardware components to make an ECU or to make an car finally. So that means vulnerabilities can be in different areas, and vulnerability analysis, which is a theoretical identification and investigation of the weakness, will help to understand it in a better way and to mitigate it. So it's basically used to identify the weakness. Finally, or using vulnerability analysis, we find a weakness which affects the confidentiality, integrity, and availability. So all the informations that is coming from the car or transferring within the car should have have its own confidentiality. It should not be altered, and all the services should be always available. So we have to ensure that. Okay. So with all these introductory things, now let's go deep into the actual penetration testing, that is exploitation. So this is the part of this SiriUs talk, the important part of the SiriUs talks, where we talk about how we do the penetration testing, the exploitation. So this is the actual testing that we will be performing. And let us see how to exploit ECU firmware. That is the first level of exploitation, that is the ECU exploitation. And in that, we will see how to perform the ECU firmware, bootloaders or operating system and HSM. These are all basically the um, part where we do the ECU exploitation. So when it comes to bootloader, how we perform the exploitation. So we extract the bootloader firmware from the ECU. So that is what the hacker or white hacker should try to extract the bootloader firmware from the ECU and do the perform the binary analysis to analyze its code, the protocols used, and security mechanisms. And then the identify potential vulnerabilities such as buffer overflows or insecure firmware, uh, update mechanisms used for the bootloader, or hard coded potentials. Basically, all these are very prone to the possible hacking. And once all these informations are identified from the ECU firmware, we should start exploiting. That is by injecting malicious firmware update, bypassing the authentication mechanisms, or executing an arbitrary code. So normally the ECU will have its own secure boot, secure flashing concepts. It has key mechanism implemented in it. But in case if it is not implemented due to cost or by considering the ECU is not so severe, by this exploitation test, we'll be able to see such drawbacks or loopholes in the implementation. So next is the operating system. So when it comes to operating system, identify potential vulnerabilities such as misconfigurations, insecure default settings, or known vulnerabilities in third-party components. So normally operating systems are purchased from a third party, and they should have a robust database where all the vulnerabilities, known vulnerabilities are listed. And a developer who does the operating system configuration should have a very good knowledge on doing its configurations and doing the sufficiently secure default settings. Otherwise, the operating system is a big source of um, doing the hacking by a known person who has a technological information about the system. So once all this pre-ground is set, uh, we should exploit the privilege escalation of the privilege, denial of service attacks, or unauthorized access to the sensitive resource. So through operating system, we can penetrate into the memory of the ECU and extract um, EEPROM or RAM area and get a lot of information related to it. So the next is the HSM, that is hardware security module. So currently, all major ECUs in the vehicle or all important ECUs in the ECU in the vehicle have an HSM in it. There is a hardware security module, which is a separate core within the microcontroller, which is used for cryptographic operations. So, and HSM contains all the private key informations and MAC verification algorithms, etc., using which the security of the complete ECU is taken care, like, for example, for secure boot or to update the software, etc. It's very much important to have such sensitive data stored in HSM, which cannot be accessible easily. So now to exploit the HSM, what we should do is we have to understand the purpose and functionality of the HSM initially. And we have to identify the potential attack surfaces here, and vulnerabilities and secure features like private key storage, etc., should be learned in this understanding stage. And once that is done, I attempt for HSM debug port access or physical tampering possibility, or for the interface probing to read sensitive information stored in the HSM can be attempted. So using this, if you are able to do, if, for example, if developer is missed to lock the debug port of HSM, it's easily possible to hack the HSM and gain all this information. So the penetration testing should ensure that it is locked. And some tool examples, the open source tools like IDA Pro or WinHex and Metasploit, these kind of tools can be used for the ECU firmware exploitation. So going further, the ECU application software. So this is another uh, big part of the software in an ECU, where firmware is about the core, which talks mainly about hardware. The application software is based on the application like battery management system or charging or internal combustion engine, whatever the application orders, etc. So what we should do here is first is the static analysis, where one should perform static analysis of the extracted software to identify potential vulnerabilities. So that can be like hard-coded credentials, buffer overflows, or insecure communication protocols. So this can be done during in the desk as a static analysis check, and tools like CoverT Scan can be used, which is an open source tool to the static analysis. And the next is the dynamic analysis, where we do basically use some sophisticated tools, hardware tools like debuggers or emulators. So it is we should execute the software in a controlled environment and analyze the behavior dynamically, like what will happen to the software when some execution conditions come across, whether there is a security weakness in it, or there is a weakness through which a malicious code can be executed in the target. So as mentioned, use debuggers or emulators and hardware probes to monitor this runtime behaviors. So tools like QEMU emulator can be used to simulate such kind of dynamic analysis. So going further, the hardware. So the ECU hardware is one of the important area for penetration testing. So the focus is of this talk is more on the software, but hardware is also one of the area which using which the software based hacks can be performed. So that's why what we should do here is the exploitation of ECU hardware, PCBs, microcontroller used, and communication transceiver used are the target of this exploitation. So what can be done here? We can disassemble the ECU, open its covering, and do the testing of or do the manual inspection of the ECU, which component is used in it, what microcontroller used, which CAN trans receiver used, etc. So a good product should mask all these critical silicons used in the hardware so that it is not readable. But if it is not masked, we can read the memory chips, um, sensors, and communication interfaces. So it is possible to perform it and attempt to identify critical chips like MCU, CAN trans receiver, and possibility of replacing it or reading their configurations. So this is another attack that can be done by an expert. They can read the microcontroller and develop their own software and just replace the chip, and then he is done. So he can tune the performance of the car or uh, violate the regulatory requirements so that he is benefited from it, like saving the fuel or saving the electricity in the case of electric cars, etc., or use the batteries full power, etc. So whatever the limits that OEM put on the car, that can be changed using this kind of security hacking. And also the fault injection techniques like injecting glitches, voltage spikes, or electromagnetic interfaces disrupt normal operations and trigger unexpected results. This can be performed on the hardware. So there is a tool like Chip Whisper that is available as a hardware tool where we can attempt all these hardware-based exploitations. So going further, the debugging and reverse engineering resistance. So it's always important to keep the IP of the product, that is software or hardware developed by OEM or tier 1 or tier 2 suppliers. So the software should not be readable, it should not be extractable. And also along with the IP, the another problem is that if someone can extract the software, it is possible to do some reverse engineering and understand the security mechanisms used in the software and then accordingly tune the software so that he can perform attack. So the cybersecurity rule says that the JTAG port, that is the debug port that is used in a microprocessor or microcontroller, should be protected from during the production. That means this debug port should be available only during development phase, and during production it should be locked, either by a password or completely locked. But it is possible that some OEMs will keep it open so that they can do some engineering work in case of any field failures. And also it may be just a missing of the case. So then what we can do here is attempt to exploit the JTAG port to gain access to the ECU firmware and memory. So with that, JTAG port try to communicate. Maybe from the hardware side, they might have removed the hardware JTAG port, but the pads are available in the PCB, using which there is a tool like JTagulator as shown here. Using this kind of tools, we can connect to the PCB pads and connect to the JTAG port. And then once the JTAG port is connected, if it is not locked in the firmware level, we can attempt to read the binaries from the ECU and then modify the memory to trigger some abnormal behaviors, like for example, ECU reset. So if you can create a ECU reset, then that is a kind of denial of service, and it's definitely not. It's definitely a problematic scenario for the user. Next is the attempt to extract sensitive information through JTAG port. So basically, once the JTAG is possible to access, then it is like we are getting complete access to the ECU. That means we can connect to the bootloader area, we can go to the HSM area, or we can definitely take even the control of application software. And we can read the UCBs or register setting of the microcontrollers. So this means that um, the JTAG port is a very serious uh, port that we are keeping open when the car goes for production. And this is like 40 plus ECUs. So there is a possibility that one or other JTAG port is kept open due to some reasons. And yeah, so the cryptographic informations are stored in the HSM. And if you have access to the JTAG port, then we can use the sophisticated tools that is available to use the debugger, and then can access or get the complete cryptographic information stored in the HSM, for example. And then that means we can do a lot of reverse engineering. So the next exploitation is the smart sensors and actuators like camera, radar, etc. So as we are going for autonomous driving, and we are doing very nice ADAS features, so that we are using a lot of actuators and cameras or radar system today, and that is one of the area where the more exploitation can happen. So what we should or what an white hacker can do here is uh, yeah, to gain the understanding of the smart sensors and actuators, such as radars, lidar, camera, brake, steering, etc. So the understanding is the key, as I'm telling from the beginning, because the understanding of the system is the key to penetrate more deep into it. And then identify the potential attack surfaces and entry points for exploiting, like Wi-Fi or Bluetooth, CAN, OBD ports, etc. So these are all the attack surfaces that is possible in an issue. And once we enter through Wi-Fi or Bluetooth, we can penetrate further to the CAN network or LIN network, and then do the attack on the smart sensors or actuators. Because all these sensors send data or receive data through one of the in-vehicle communication, ISPI or CAN or LIN. So once the hacker enters into the network through external connectivity, then it is possible to take control of this. So we have to identify the potential attack surfaces there, and then use the protocol analyzers or snippers and reverse engineering techniques to intercept and analyze the traffic. So the data that is going through the in-vehicle network can be snipped and do some reverse engineering or continuous analysis of the data, which will give an idea of what exactly that is transmitted or received through that network. And then we can apply fuzzing technique or tampering techniques to attempt to bypass the authorization to tamper the data or for denial of service. Okay, so we talked about ECU exploitation. The next exploitation is connectivity exploitation. So as we all know, the cars become more connected nowadays, and it has all the connectivity in it. The connectivity exploitation is very important. So let us see how to exploit. Initially, let us see how to exploit the in-vehicle network, that is like CAN or LIN or Ethernet. Yeah, the major penetration testing that can be done on CAN network is fuzzing. So fuzzing is basically where we check the resilience of the ECU firmware against malicious inputs and unexpected behavior. So what we should do in fuzzing is generate and inject invalid or unexpected data in the canvas and to trigger potential vulnerabilities. So that means for example, some of the CAN IDs, we should start randomly from 0 to FFF or to the maximum possible CAN ID and try to attempt to do it. And also try using different types of CAN data or not following the CAN protocol and send continuous data. So these kind of fuzzings will show us any vulnerabilities that exist. And another thing that can be done on the CAN network or LIN network is attempt of denial of service by creating bus overflow or continuously transmitting the fake high priority CAN message. So as you know, CAN is a broadcast bus where the CAN signal with high priority is always wins the bus. So then if you create a fake high priority CAN message, then it may end up in denial of service for the important, needed, and authenticated CAN. So we can test whether CAN implementation is robust enough for that. So the tools that can be used, we get a lot of USB to CAN adapters where we can connect it to the PC and send CAN signals through it. There are USB to LIN converters available that also can be used. And some software tool example like Socket CAN, Wireshark, CAN Sniffer also can be used here. So next, let's see how to exploit user connectivity like Bluetooth, Wi-Fi, or USB, etc. So here what we can do is exploit a flow in the Bluetooth stack or Wi-Fi drivers by referring to the version of software stack. So we normally take Bluetooth stack or Wi-Fi drivers from some third party, and that version may be old because a car will be used for many years. So the stack update is needed. Maybe it has a very severe vulnerabilities, so we can exploit a flaw in it. And then attempt for information disclosure by reading private informations in the contact list or address book. Uh, this is basically with the Bluetooth or with the mobile connectivity. We can try to get this kind of personal informations because as per cybersecurity, personal information also should be protected. And if there is any possibility to get exposed privacy, that is also one of the not one of the violation for the cybersecurity. Next, attempt to access the internal vehicle network and then set up a yeah, identify attack surface, exploit a flaw in the Bluetooth. Attempt to access the internal vehicle network through this connectivity and then set up fake dealer access points, for example, to trick the vehicle thinking it is being serviced. Because in a vehicle, normally in the dealer access points, there are a lot of other features that are available, which is not available for a normal driver. So if you set up a fake dealer access points through some rogue networks, then vehicle is more exposed. And that time we should see whether some cryptographic informations are exchanged or whether some critical or personal informations, private informations are leaked in the network. And also we can set up a rogue wireless access points to perform evil twin attack, as we seen in the Tesla hack in the first slide, where we can use the tools to perform a rogue wireless access points and to see whether any important or critical data gets exchanged. So here we can use tools like Flipper Zero or Wi-Fi Pineapple, Blueprint, Ali Snipper, these kind of tools which is able to snip the data. And also there are softwares available like BT Scanner, Blue Mahu, Midtime AP, etc. So going further, the connectivity exploitation about remote access, remote services like mobile app, over there update, etc. So how to expose that? So understand the communication protocol, encryption, authentication, and backend system of the OTA update. So it's important to see how OTA works. Then identify the attack surface like as usually we do. So understand Wi-Fi or cellular, which is the attack surface. Then attempt techniques like sniffing, buzzing, man-in-the-middle attack, or to inject malicious code, and to read firmware or to deny the over-there services. So here we can use the hardware like Blade RF, for example, which is a sophisticated mobile setup or RF setup hardware. So using which we can set up a 4G or 5G network, and then we try to snip the data or try to prompt the user to access this network and then try whether we can hack that networks. And we can use the tool like Yate BTS from the software. So it is basically a software defined radio, or SDR it is called, which can be used. So going further, the last connectivity exploitation, that is the diagnostic port and key port. So when it comes to diagnostic port, attempt for critical vehicle service activation or deactivation via direct access OBD port can be tried. because OBD is possible to connect through outside or third party devices. So using which we can do the critical services activation and deactivation. And then attempt to execute UDS services through OBD ports by bypassing authorization can also be attempted. Yeah, there will be a security mechanism. There is a seed key algorithm, but it is a simple seed key algorithm and possible to hack in many cases. So, and if that is hacked, then it is possible to penetrate further into the vehicle network. So, so next is the key fob, where a lot of hacking is happening in recent days. So basically, it's a simple RF communication, and there will be rolling counters and rolling signal changes and authorization, but there is a possibility actively possibility to hack it. And how we can do is actively probe the immobilizer to drain the battery and capture cryptographic information leaked from the immobilizer during this handshake. So this can be attempted, and even it is possible to um, hack the complete car and drive away with the current technology where we have the keyless entries, etc. Yep. So with that, we ended up exploitations, and then next is this post exploitation. So what is post exploitation is like once exploitation is completed, mm, it is basically going deep into the further into it. So the persistent access to the target, where we can try whether we can do this kind of hacking further into it. And then escalation of privilege to memory register level is also we can attempt. And finally, we can pivot deep into the vehicle network for man in the middle attack or denial of service, etc. This can be attempted. So the importance of post exploitation is to check whether the hack is happened by chance or it is by design itself. It is hackable. So that's the how deep we can go. And finally, we have this final step of the framework, that is reporting. So this is an important step because all work done by a pen tester is now visible to outside world. So first, all identified risk and vulnerabilities should be listed. And next, the executive summary of pen testing should be prepared, which will help the product management team to take decisions on further actions. And finally, there should be a detailed report of exploitation, as well as where all test cases and test reports are available. Okay, so with this, we come to the end of the penetration testing. But before going to Q&A, we have this slide where we are having our offerings in cybersecurity from SiriUs. So we can help OEM, Tier 1, Tier 2 suppliers regarding the regarding their automotive products or solutions in the areas like threat analysis and risk assessment, defining cybersecurity goals and requirements, and developing an embedded security architecture. Also, when it comes to ISO IC 1434 standard and its realization, we can help to prepare artifacts for CSMS certifications and to develop cybersecurity culture in the organization. And we have our core strength in the supporting development activities as well, like HSM firmware development or its integrations, developing security controls like secure boot, secure flashing, secure onboard communications. We also support for penetration testing of customer functionalities, automotive components. So basically, our support for cybersecurity starts from concept phase and until decommissioning, which includes operations, maintenance, and incident management. So with all this, let's go for Q&A in the next 15 minutes. Yeah, over to Naresh.
Thank you, Ishwara, for that insightful presentation. Now, let's take a questions. Yeah, please feel free to submit your questions through the Q&A window. We will address them in turn. Yeah, Sanjay, you can ask question in Q&A window. Yeah, we have a question, Ishwara. So, is there any difference between this penetration testing report and I guess it like Tara test report?
Okay. Um, I believe Tara is actually the what I can say. The penetration testing is a physical testing, whereas Tara is a theoretical evaluation of the security weakness or threat factors or attack paths, attack visibilities, etc. in a system. So theoretically, using Tara, we can do the investigation deep. That is basically by having a team of architects, developers, system engineers, safety experts, etc. sit together and perform the asset identification, find out what all the attack paths that are there and what is the feasibility of attacking it, and based on that, develop a cybersecurity goal. So the report from Tara is basically a systematic theoretical analysis output. Whereas penetration testing, it's different. Here we are doing the exploitation along with some theoretical analysis like vulnerability analysis or threat modeling. But the important part here is basically the penetration testing, the exploitation. So the report should contain all physically tested vulnerabilities also, along with the theoretically identified and or proved one, as this is possible to hack. So this is basically the difference.
Yeah, we have one more question. Yeah, before. Yeah, is there any solution for penetration like testing? Sorry, phishing attack on Tesla car?
Okay. Yeah, that is a good question. Actually, Tesla denied yeah, the when someone informed about this kind of hacking or phishing attack. The thing is that phishing attack, how it is done here is by setting up a rogue Wi-Fi network. That means it is not that easy to avoid phishing in this kind of scenarios. But what Tesla can do here is to provide some kind of advanced two-factor authorization. Like for example, when we have some apps in our computer, it will ask for a two-factor authorization in our mobile. Or we can send, or this Tesla, that what they can do is they can send an SMS instead of sending the code to the same network of Wi-Fi. This two-factor authorization code, because two-factor authorization code means it is a second authorization, and sending it on the same network is always dangerous. And also driving away the car is was possible in Tesla because they believed on the keys that is existing in the mobile. So they have another the Teslas have keyless driving, but they have a card, the smart card, which is used for authorization, and that should be checked along with the mobile to allow the user to drive a car. Just believing only on the mobile authorization might be a problematic. So yeah, that is one way of avoiding phishing by advanced two-factor authorization. So you can reach out us on this contact. Please take a our contact here, or you can ask questions through that also. We'll try to answer. Yeah. Thanks for your attention. Yes.
Thank you all for joining.
Yeah. Thanks all of you. Have a nice day. See you. Bye bye.